Hi, welcome to In 5 Minutes. In the previous video, we have seen the construction and working for the D Mosfet. Now we are coming to the E Mosfet. Now what it is? Enhancement mode Mosfet, metal oxide semiconductor field effect transistor. Now what you can see, the construction is very much similar to the D Mosfet, but you can say how the current is controlled. Current is controlled in N channel device. D Mosfet mein it is controlled by the negative gate voltage, whereas in E Mosfet current is controlled by the positive gate voltage. This is the difference between the working of D Mosfet and E Mosfet. D as well as FET, you have the current controlled by the negative voltages encountered for N channel JFETs and N channel D Mosfets, whereas we are control the current by using the positive gate voltage. Now coming to the basic construction of the E Mosfet, you can say it is again a P-type substrate on which we have N-type doped regions which are connected via metallic contact to drain, gate and source terminals, and we have the substrate terminals. When we are connecting substrate terminal with the source, it is 3-terminal device, and when the substrate terminal is separate, it is a 4-terminal device. So what you can say, construction is very much similar to the D Mosfet, but the channel is not existing in the E Mosfet. That means for the flow of current, channel should be formed, or we need to create a channel in order to flow the electrons from the drain to source. Now what will happen, we'll come to the working. You can see here, gate is made positive, that is the positive terminal will attract more number of electrons from this P substrate. So what you can say, the holes are now repelled away because of this positive charge, and they will away more deeper into the P substrate. As we have seen in the working of the MOS capacitance, the same effect is used over here. So in order to understand the concept, you should know the MOS capacitance. When gate is made more positive, the electrons are now attracted more towards the silicon dioxide layer, which is nothing but the insulating layer. But as there is no contact between the gate terminal with the substrate, so the electrons just accumulate near the surface of the silicon dioxide layer, but they cannot move to the gate terminal. That means we can say, if VGS is 0, what will happen? And if you are applying VDS, that is this voltage, if it is greater than 0, since there is no channel formation, what will be the amount of current? Current will be 0 in this case. Now in the next case, what I will do, if I am applying VGS greater than 0 and if my VDS is again greater than 0, that means positive negative, positive negative, that what it will cause, it will attract more number of electrons on the edge of silicon dioxide layer, right? And the holes will enter deeper into the P substrate. Then a depletion region, you can see over here, a depletion region is formed because of this. You can say P type, we are connecting positive, right? P type, we are attracting more number of electrons. That means we are creating a depletion region over this part. So a depletion region in this way is formed, which will attract more number of electrons towards the silicon dioxide layer. Now however, the electrons in the P substrate will be attracted to the positive gate and accumulate in the region near the surface of the silicon dioxide layer. They cannot move into the gate terminal, as I have told you, because there is insulation, or you can say insulating layer of silicon dioxide, which will not allow the movement of electrons into the gate. Hence there is no current in the gate. We can say Ig is 0. Now what will happen after this? When we are connecting positive terminal, the electrons will be getting attracted towards the positive terminal of the battery, and the movement of electrons will be in this format, or you can say in this direction towards the positive terminal of the battery, and whatever electrons we are losing, you can say it is provided by the negative terminal of the battery. This is the actual flow of electrons in the E Mosfet. But the conventional flow of current, you can say direction of current, you can say ID, is flowing from drain towards the source. Now if my VGS, as my VGS is increasing, what will happen? The concentration of electrons near the silicon dioxide surface increases until there is flow of current. flow of current will be from drain to source. The point from which there is significant increase in the current ID, that point is called as VT, or you can say threshold voltage. Which voltage? The level of VGS that results in the significant increase in the value of ID is called as threshold voltage. What we can say with for VGS 0, there is no channel present for the flow of electrons, and as your VGS is positive, it is enhanced by the application of plus VGS, and hence it is called as enhancement type MOSFET.